everybody, it's old SHAZIZZ here. For those of you that take the time to try to understand what it is I'm fixing to show you, you're going to be quite pleased with your future research and energy. And so in this video, I'm not going to say a whole lot about what's actually happening outside of explaining to you how the system's set up, and then I'll let you do your own determinations. But to start off, we're going to test the voltage of this battery right here. Alright, so it looks like we got 7.74 volts in this heavy duty 9-volt battery, Dollar General store brand. Alright, so that's all the voltmeter work for right now. So basically, what we got going on here is I built a custom transformer. There are 2 coils on this side and there are 2 coils on this side, both of which have exactly the same amount of wire. Not even sure what gauge it is or whether it even matters, nonetheless. It's just a transformer, so guess this would be classified as a 1-to-1 transformer, but that's not exactly how I'm running it. So anyway, the primary on this side and the primary on that side, I am running as if these were one with a midpoint ground. So I'm running them separately. This yellow wire and this black wire are these 2 separate coils that come together right here in the center for a midpoint ground, and these, one of each, the side of the coil, each side of each coil is now my positive and my negative for this battery. And so on this side right here, we have a secondary, which is these green wires that go over here to this neon bulb. And on this side, we have a secondary, which is this red wire, these 2 red wires, which goes over here to this neon bulb. Alright, so I'm going to go ahead and I'm going to connect this right here just to show you my transformer works, but this isn't what I'm actually trying to show you. For those of you who pay attention to what it is that I'm trying to show you, and understand what it is that you're seeing, right there we have 2 neon bulbs running off of 2 separate secondaries on the same transformer. The secondaries are separated by the ferrite core. That's it. I hope you can see that lighting up in there. I'll have to wait and see. For some reason my computer is slowing down and acting a fool. Alright, so basically what you see there is what you see in this diagram right here. I'm going to try to get that in there. So this is a primary off of one side, is my positive. Primary off the other side is my negative. And then the opposite side of each of those wires is now my midpoint ground. So basically turning this and this coil into one coil on opposite sides. The secondary makes a loop from, you see those go over the top there, they're not connected, they go over the top. It makes a loop from that neon bulb, and then the opposite side of the one goes to that neon bulb and does the same thing on the other side. So 1 and 2, that's a primary and a secondary, and then a primary and a secondary over there for 3 and 4. So that's how the circuit's set up. That's what you see whenever I'm taking this right here and turning it back and forth. You see those 2 bulbs light up. just for, let me see if I can get this down in there closer, because I'm not sure if you can actually see that on this film yet. I'm going to put it right there. Alright. I'll have to look at this on a playback to see whether or not you can even see them lighting up. Okay. So let's put this back up here for a second. So, in order to complete a circuit, you have a coil, then you have the wire going out to your load, and then you have your load, of course, and then on the opposite side you have it going back inside there. So when I induce a current into this coil right here, I light up that light bulb because it's a completed circuit. When I induce a current into this coil right here, I light up that light bulb because it's a completed circuit. I'm hoping you're seeing that, but I'm going to have to wait till I play it back to find out. Alright, so it's my understanding that these two little neon bulbs, anywhere from 60 to 90 volts it takes to energize that gas inside there. So now I'm going to show you something different. And for those of you who actually take the time to understand what it is that I'm showing you, you may reconsider how you build generators from that point on. Alright, so what I'm going to do, if I can get my hands to work, so I'm going to take one there, and I'm going to take one, if I can get my fingers to work on that too. I'm trying to get them both on the same one, and it's not cooperating. Yeah, burn it, come on. Alright, so there we go. According to how a circuit functions, that metal bulb should not light up because this right here completes a loop closed circuit. This right here completes a loop closed circuit. And so we're going to energize our battery again. And you see that all three are lit up. I know that I'm going to catch a lot of craziness for what I'm showing you right here. But if you understand the implications of what I am showing you, let's just say you'll be pleased in your research in alternative energy. Now, I did a video called Rotary Switch. In this video, you see me basically doing what the rotary switch would be doing. Alright. Now they got things that they call commutators, but commutators, they got problems. But if you take these hard drive bearings, like this right here, and you have 2 points of contact, not touching each other, but 2 points of contact, as these are rolling by and they hit those two contacts, it touches the connection on the battery. So it's going to make and break that circuit. That is the key that you need to recognize, is that you want it to make and break the circuit. So if you look on this diagram right here, you'll see that there are 6 of these precision bearings out of hard drives. If you look closely down here, I did a cutaway view. These are the switch contacts. So you have your battery, then you got your negative out going through your primary, and then there. So every time one of these rollers comes around and touches those contacts, it makes the circuit and pulses that, energizes that right there. If you understand what you saw here, you'll understand something cool about what's going on here as well. When you pulse this and you understand what's happening right here and understand what's happening right there, then I think you're going to be pleased. This would be the secondary on your transformer, would be now an output. This is just a little mini view of electric motor running this, just a side view of what's going on. This is a rotary switch that I've been talking about. If you can get somebody to actually build a precision rotary switch for you, you can use it to pulse any transformer using a DC battery. And if you understand what I just showed you in this particular video right here, you'll see a completely different method on how you can catch the flyback from 2 separate transformers that are also running a load. This is a completed circuit. This is a completed circuit. These are 2 separate transformers lighting up this middle bulb. And I don't know if you can actually see it in the video, but the middle bulb is a lot brighter than the 2 outer bulbs. I will try to put the camera down there one last time and show you. As I make the contact, make and break the circuit. That's the key. So keep in mind, the middle one is not a completed circuit with one coil. The red one is one coil. The green one is a separate coil on the opposite side of the transformer core. And the primaries on both sides are actually being ran like a midpoint ground, but also on the opposite side of the transformer. I must have bumped it. Let's try that again. Alright, well, this video is like 13 minutes long now. I'll give you a closer view of this right here. That's what you just saw. Pause that, take a picture or a snapshot of it, and replicate it. That's the transformer. Heavy duty 9-volt battery that was about 7 and some odd volts. Now, when you measure the output voltage on there, you might be surprised. So, with that said, one last look. Get that up there. Folks, I'm putting this one, doggone it, trying to get it centered again. My camera's slowing. I'm putting this one little nugget out there for serious researchers. And if there are some serious researchers that really want to talk about getting things done, have them join me over at SHAZIZZradio.com. Saturday mornings, 8 a.m. to 11 a.m. Central Time. And on Sundays, same time, same place. But at least hear me out. Peace and love, everybody. Take care.